This is figure 3.6 from the book, indifference curves with a neutral good. So the example that the book gives is a pizza with two topping choices, pepperoni and anchovies. And so in this case, our consumer likes pepperoni, they want to consume more of that, but they're indifferent to anchovies. If there's 5 anchovies or 20, it doesn't change their utility at all. And so as a result, our indifference curves are going to be vertical because if you change the number of anchovies, it doesn't change the utility. So as long as you're moving along this curve, it doesn't change anything. But as you increase your consumption of pepperoni, you need to draw a new curve because they gain a greater utility from consuming at this point. And so another example that's maybe a little more realistic is, say you have a phone contract and it basically allows you to purchase your monthly quotas of minutes of calling and minutes of texting. And so since, say, a lot of people don't really call anymore, the amount of minutes they have on their calling plan is irrelevant to them. They're indifferent. So we relabel this access call. But they text all the time, so the number of minutes they get for text is very important to them. We'll label this access. And so same thing, the more minutes they can get of texting, the greater their utility. And if this good is monotonic, you're always going to want to consume as much in the direction on the x-axis as possible. And so an interesting result we get is, say we put in a budget constraint, some line like that, where would the ideal bundle be? Well, because the indifference curves only increase utility as you go in one direction, it basically sort of eliminates the good on the y-axis as important to us. So we don't really care about this one anymore. We're indifferent. We only want more of the good on the x-axis, pepperoni, texting minutes, whatever. And so even though the curves have a vertical slope, and the slope is really undefined, we're always going to have a corner solution here on the x-axis because the utility is always going to increase with more consumption of x. And so your ideal bundle will always be the x-intercept m over px. And that's basically what a neutral good does, makes one of the axes sort of irrelevant, indifferent to your consumption of this. We only care, and our utility only increases with more consumption of the good on the x-axis.